Hello, welcome back to another video. In this video we're going to be speaking about composite functions, an introduction to composite functions. It's a simple concept, so relax, free your mind from distractions, and let's start learning. Composite functions. Okay, what are they? Well, composite functions could be thought of as a series of functions or a combination of functions. This may seem all abstract for now, but you'll see why. It's a series of functions or a combination of functions. And if you want to return to the old analogy about function in terms of function machines, then we could think of composite functions as a series of function machines. That's how we represent them. Here's why. First, let's go through function machines. Let's think of composite functions as function machines. First, let's go through function machines. Let's think of composite functions as function machines. And remember, functions could basically be thought of as machines because they execute a process, inputs, outputs. So let's do that here. Let's say we have our function machine. Takes in an input, and we have our function here, or function machine. F of x is equal to 2x. And then that would give us an output, and we would take that output to continue this series of functions, which would make up our composite function. So we take the output and put it in this function machine, or this function defined by f of x is equal to x plus 1, which would give us our ending output. Okay, let's go through an example here to see how this plays out. Let's say we have 2. We input 2 into the function or function machine, and that's basically plugging in. We plugged in 2, so f of 2 is equal to 4. Now we take this output of 4 here, and then we would input it into our next function in the series, or next function machine. Plugging in again, f of 4 is equal to 5, and we would end with our ultimate output. All this makes up one function, the composite function, because here we see a series of functions starting from 2 and ending with 5, going through 2 functions, a series of functions, which make up the composite function. Notice here it says input/output. Why is that? Well, that's because we've taken the output from the function f of x is equal to 2x, which is 4, plugged in x is equal to 2, or 2. And we took that output, and it became the input to this function. So we plugged in 4. This is how composite functions work. We take the output of the first function in the series of functions, and we plug it into the second function in the series of functions that make up a composite function. So there must be a mathematical way of writing all this. And yes, there is. Here's how. Let's express the idea of composite functions mathematically. We're going to do that by completing or returning to our function machines example, which represents a whole composite function made up of these 2 functions or function machines. Okay, what we did is we inputted 2 into f of x, and so for that we just have to plug in 2, and we would get 2 times 2, which is 4. Then we took this 4, and it's an output from f, and we plug it in to g of x. Again, plug in x plus 4 plus 1, which is 5, and we have the output of 5. Great. Now let's use this idea to write composite functions mathematically. For that, we need to focus on one specific idea within this analogy, which is, notice here that we plugged in 2 into f, and then that would give us an output. That's obvious. Then we took that output, which is a value of f from here when we plugged in. We took it and we plugged it in. We plugged it into another function, which was g of x in our case. So what are we doing here? Well, we could say in general, we're plugging in a function here, f, into another function, g. Great. Normally, we would plug in x into functions, right? But now we have g, and we're plugging in f into g. Again, we took f, its output, and plugged it in to g. So f is an input to g. Great! We wrote it here. Instead of x being the input, f is now the input. That's how you write composite functions. G of f of x. This is a composite function. It's made up of two functions where one is the input to the other. So now we have a better idea of what composite functions are, and we have a mathematical representation. We could also write this. Now don't get confused, this is just notation. It looks like fog, but what it really says is f of g, and this hollow circle isn't a multiplication sign. Okay, so these two things are equal. This is how you write composite functions. Now let's use our functions above to the composite function we have in the example specifically. We'll do that by using this notation here. Alright, so we have our function g, which we know is x plus 1, and we have our function f, which we know is 2x. Okay, and we're plugging in one into the other. Composite functions. Let's do that. So we could write g of, instead of f of x, what's another way to write that? Well, we know f of x is equal to 2x, so we'll write 2x. Here we know, and we know g of x is equal to x plus 1 again. And in this case now, we're plugging in 2x instead of x. So we would plug it, so we would write 2x instead of, in the place of x, plus 1. And we have found our composite function. This is g of f of x, which is also f of g. And we could call this whole thing just some function c of x. What if we plug in 2? Again, like in the example above. Well, we would have this function we called c of x, which is equal to g of f of x, which is equal to g of f, and which is 2x plus 1. Let's plug in 2. So we have c of 2, which is equal to g of f of 2, which is equal to g of f of 2, which is equal to 2 times 2 plus 1, which is equal to 5. Great, we ended up with 5 again. 5 and a 5 up here. Thank you for watching. See you in the next video. My email is down below. For any math-related things you want to send me, questions, suggestions, and a written version for this lesson. Okay, see you in the next one, which will be about composite functions as well.